Hello and welcome to another video, 875, Koko Eating Bananas. So, Koko lives to eat bananas where there's n piles of banana and the ith piles has piles at the index bananas. The guards have gone and will come back in h hours. So Koko can figure out her bananas per hour eating speed of k. Every single hour, she chooses some piles of bananas and eats k bananas from the pile. If the pile has less than k bananas, she'll eat all of them and will not eat any more during this hour. She likes to eat them slowly, but wants to finish eating all the bananas before the guards return. What we want to do is return the minimum integer k such that she can eat all bananas within h hours. Okay, that makes sense. We're given this example over here where the input is an array of all the piles of bananas over here. So we can go ahead and put that over here. We have h as the number of hours that within h hours. So she has to eat it within h hours because the guards are going to come back from then. So we have h over 8 here. And then for the output over here, we return 4 because with 4, every single hour, if she goes ahead and eats this, she eats the first pile. It'll take 1 hour for her to eat the first pile, so it'll take 1. It'll take another 2 hours for her to eat the second pile because 4 plus 4 is 8, and it'll take still double the amount of time. For the third one, it'll take her still 2 because it'll take her 2 hours to eat all 7 bananas in this pile, and for this one, it'll take her 3 hours. And 3, 4, 5, 6, 7, 8. H is exactly 8, so that's the minimum amount that she can eat in order to fulfill the constraint of the guards coming back within that time and all the bananas being eaten. Okay, this makes sense. So one way we could take a look at this is figure out which number k. Well, what we want to do is we need to choose which number k in order to eat all the bananas within a specific time constraint. So if we take a look at the possible values of what k could be, well, k could be one of the smallest values in the piles over here. So it could be let's say k equals to 1, right? If k is equal to 1, it'll take 3 hours for Koko to be able to eat this pile, 6 hours for her to be able to eat this one, etc., etc. It won't be that efficient, so it'll end up taking the combination of all the sum of these values in order for her to eat everything, and that's not really good, right? Now, the next thing we could do is choose the maximum amount here. So let's say we have 11 over here, right? So, if Koko could eat 11 bananas in an hour, then she'll be able to pretty much one-shot all of these values over here, right? So it'll take her 1 hour to eat this, 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 and the total result will be 4, which is basically the length of the array itself, right? So it'll take her 4 hours in order to eat it, which is much less than what she needs for 8, but it's probably not the minimum integer that she could have, right? So 111 over here. So somewhere within 1 and 11, there lies a value 4, 5, 6, 7, 8, 9, 10, 11. There lies a value in which the amount that she eats will cause the number of hours it takes to eat to be exactly the constraint, which is 8, and that's where the minimum integer that we can find will be. So we know from this example over here that the output is going to be 4 because at the constraint 4 over here, h is going to be exactly the 8, and the number of hours she's going to eat is also going to be exactly 8. So how do we arrive to that solution? Well, one thing we could do is basically traverse through every single element here. Let's say 1 in this range between 1 and the maximum amount in this initial piles array. We could traverse through, check to see basically how long it'll take if k was set to that amount by doing how long does it take for you to eat 3? It'll take 1 hour. Like it'll take 3 hours, it'll take 6 hours, 7 hours, it'll take 11. And then we same thing for this one, 3 and 2. It'll take it'll take 2 hours for this one, it'll take 3 hours for this one, etc., etc. We can basically figure it out, and once you reach the amount in which it'll equal 8, that's where you'll eventually return your final result. And we know for that situation that final result is going to be 4, right? So okay, let's put some more detail into this. How do we figure out basically what the how long it takes for that? Well, what we have to do is for every single for every item in piles, for P in piles, right? We have to figure out how long it'll take by dividing the amount, right? Piles I. You have to divide that amount by K, which is by the option over here. So K over here, and this will return the amount of hours, right? And then about causa K, sum up all 4 results. So we know that, right? And we want to take the amount in which it's equal to K. So we take piles I, basically sum that is equal to 8 is result, equal or minimum sum that is less than or equal to 8 is the result over here. Now, if we take a look at this and think about it, the time complexity of this solution would be O of P, right? O of P, where P is the maximum amount in this subarray over here, right? Well, so the time complexity for every single element in piles, right? So it's already O of n over here. We have to figure out we have to figure out for every single element between 1 and the maximum. So we can assume that, let's go P is the maximum, right? Or let's say M is the maximum, right? So for every single element in the maximum over here, right? For between 1 and the maximum, we have to iterate through every single element in that pile. So it'll be an O of M times n solution over here, if I'm not mistaken. Now, a way to make this faster would be to utilize binary search. So we can utilize binary search by, instead of iterating through every single element and checking to see what K is, we could have a left pointer and a right pointer over here, and we can check what the value at the middle is. So we can have basically a pointer at the left plus right divided by 2, figure out what the middle is, and it'll, in this case, the middle is 2, 3, 4, 5. 1, 2, 3, 4, 5. Middle is 6 over here. So we can go ahead and check to see whether or not for 6, let's say 6, how long does it take for this? It'll take 1 hour. How long does it take for this? It'll take 1 hour. How long does it take for 7? It'll take 2 hours. And for the last one, it'll take 2 hours. So we can sum up all those together. 4, 5, 6. 4, 5, and 6. It'll take 6 hours in order for you to do it, right? Where 6 is less than 8, right? So in doing this, you're actually able to get it done in 6 hours. But the thing is, you're not actually hitting the number of hours that you could possibly use, right? Because you could possibly use up to 8 hours. So that gives us the knowledge that if the result, right? Let's say if result is less than the H, right, the current result, then we know for sure that we can basically check the amounts which are less in order to effectively use up all of the hours that we do possibly have before the cops come back, or before the guards come back. So in this situation, we have 1 to 6. We know that 8 is larger than 6. So in this case, we can move the right one to equal R minus 1, right? Move the right pointer move the right pointer to equal M minus 1, and have it to 5 over here, find the minimum of that, and then check to see what the sum is of 3 over here, and determine what the value like how many hours it'll take for 3 over here. So if we do that again, we can do 3. We can do like how long will it take for the first value. It'll take 1. It'll take 2 hours for the second one. It'll take 3 hours for the third one, and it'll take basically 4 hours for the last one. So 4, 5, 6, 7, 8, 9, 10. Wait, yeah, right. 4, 5, 6, 7, 8, 9, 10. Well, we know that like if the result is greater than h, then that's not a valid solution because it has to be done before the guards come back at that amount, right? So that means in this situation, it's no longer valid, and what you have to do is then move the basically like okay, so for this one you do r minus 1, right? You want to check the first half of check first half, and then by doing r equals m minus 1, and then for this one you want to check the last half, so left equals m plus 1. So in this situation, we'll do it again. We'll move the left pointer to equal m plus 1 over here. We have 4 and 5. We get the middle. We floor it down. It's 4. So we go ahead and check to see what the middle is, and we know if we sum it all up, it'll be equal to 8, right? Because it'll take. Let's just do it. So we do for the value 4, it'll take 1 hour. This will take 1 hour. This will take 1 hour, and this will take 2 hours, right? 2, 3, 4, 5, right? It'll take, okay, so for this one, let's do this again. For 1 over here, it'll take 1 hour, it'll take 1 hour, it'll take 1 hour. And for this one, it'll take 3 hours because you have to do 4, 8, and then 12. So 3, 4, 5, 6, it'll happen in 6 hours over here, right? And then if we try to do it for 5, for example, we do 1 plus 1 plus 1 plus 2, yeah, 1 plus 1 plus 2 plus 3. Oh wait, right. For 4, it'll actually take 2 for the second one over here. Sorry, let me just think about this again. Okay, so it'll take 4 if we have k equal to 4, then it'll take 1 hour for this one. It'll take 2 hours for this one. It'll take 2 hours for this one, and then it'll take 3 hours for this one. 3, 4, 5, 6, 7, 8. So it'll actually equal 8 over here. Right. So like that's how we arrive at our final solution for the output, for example, 1. So we could effectively use this like a binary search in order to complete it in like a logarithmic time scale. So in this situation where n is equal to the amount in the array and m is equal to the maximum amount, we could do like O of n times basically log m over here, and this will be what our final time complexity will be if we utilize this algorithm. So if that makes sense, I'll go ahead and begin coding it up now. So we go ahead and basically set the left and the right equal 1, and then the maximum of the piles array, right? That's a linear operation over here. Next thing that we're going to want to do is we want to check to see like while left is less than or equal to the right, we want to check to see what the middle is. So we do m is equal to left plus right divided by 2. Or okay, to make it more simpler, actually we can rename this to equal k, so it matches what we were talking about for basically the problem statement over here. Okay, so we have while left and right is less than or equal to r, we figure out what the middle kth element is over here, and then we want to check to see what the total amount of time for the hours is going to be. So we're going to have some sort of accumulator value which keeps track of that. So we can have total time equal to 0. Now, for every single element in the pile, right, for p in piles, we want to determine what the sum is for all of them. So we want to do total time plus equal the floats of p, right, of the floats of the right. We want to check to see whether or not it's the floats of the current elements, right? So p divided, and we want to divide that by basically k, right? And that makes sense. One thing we also have to watch out for is, because it's talking about like the, like for the p in the piles, even if it like takes like for example, like for this one it'll be up to 8, right? If we do basically, if we set like k to equal 4, and it'll take 8, it'll take 2 hours total. The maximum is 8, but we want to floor the ceiling up, so it's better so that we have like some space in the time left over in order for us to be able to eat the bananas, rather than like you not have enough time to eat the bananas. So what we can do then is, there's a Python inbuilt function for this, or from the math library, called math.ceil. So we want to set that, basically keep that in mind as we're totaling up the amount of time. Now, after we do this, we want to check to see if total time, right? If total amount of time it takes in the pile is less than or equal to h, which is, yeah, right, which is the amount that we're like aiming for, we want to effectively set the first half by doing r equals m minus 1, or in this case k minus 1, because that's like the middle over here. Now another thing that we can do, in order for us to return the final result, we need to actually have a accumulator which keeps track of the result. So we'll have result equal to an arbitrary value, like the maximum, because that'll always be possible, and we'll do k, or like res equals min of res, and then the current amount available, which is k at this point, right? Because that's the middle. Now, otherwise, if this doesn't exist, we want to do the opposite, right? So we want to do left equals k plus 1 over here. And at the very end, what we can do is return the result. Go ahead and run this just to verify again. We are accepted. Let's do a submission. There you go. Fully accepted. Thanks for watching.